Application of trig functions. Suppose T represents the average monthly daytime high temperature in Sacramento at time X months since January 2022. So let's pick this apart a little bit. We've got an input variable X, which stands for the number of months since January. So February, for example, would be X equals 1, March would be X equals 2, and so forth. And then T, the output variable, is the average daytime high temperature. So take all those daytime highs, average them out for the month. That's what T represents. Well, here is a function that can describe that relationship throughout the months of the year. And we want to graph that function on the calculator. Of course, one of the things we're going to have to decide is what window should we use? That z-trig window, that's not going to work here. This is a real life situation. We're going to have to think about the meanings of the variables so that we know what portion of the screen we want to see. Let's start with x. X is the months. Well, let's say I want to see a 2-year period. Then I'm going to have to start at 0 and go out to 24. 24 months would be 2 years. And then what should I count by? It's up to me. How about I count by 2s? So 2, 4, 6, 8, etc. This way of writing down the window represents the minimum x, the maximum x, and the scaling for x. How about for y? What shall we use there? Well, y, or in our case T, is the temperature. We're going to be measuring average daytime highs. Now, we don't get into the negatives here. We don't even get down to 0. But I think I would want to start at 0 just so I can see the axis in the picture. And I don't think we would go over 100 in terms of an average daytime high for any particular month. 0 to 100, counting by 2s, that would make too many markings. How about I count by 10s here? And so again, I have my y minimum, my y maximum, and my y scaling. Let's go to the calculator. Okay, I'm in radian mode, so that's good. I'll go to the y equals area, clear out whatever was there, and then type in my equation. Be careful here, I need to close the x minus 3, and then I need to close the sine function with the parentheses. And now that I've got my equation typed in, I can go to the window area and put in the numbers we decided upon. 0, 24, and 2 for the x numbers. 0, 110 for the y numbers. And then hit graph. And the calculator draws us a graph of this particular function. I've copied the function here. Let's analyze it a little bit. Remember, this is our x-axis. The months, we had decided to count by 2s. Here's our y-axis, or in our case, the t-axis, and we had counted by 10s on each little marking. So that's helpful for me to remember. We are seeing 2 years worth of information because we went out to 24 months in the end. Well, let's look at some of these questions. The first question, what is the period of this function? It is clearly periodic. It is a sine function. How far do I go out before the whole cycle repeats itself? And you can see quite easily that here is one cycle. Once you get to this spot right here, it looks like the whole thing starts over again. Well, what is that spot? 2, 4, 6, 8, 10, 12. Looks like our period is 12. That should not be surprising. There are 12 months in a year, so of course this information is going to produce 1 year's worth of info, and then that info will just repeat for every subsequent year. The period is 12. Second question, when does the lowest temperature occur, and what is that temperature? Well, that's pretty easy as well to see off the graph. The lowest temperature appears to be the one at the very beginning, which then repeats, of course, 12 months later. Well, what would the beginning be? Let's see, that would be an x value of 0. X stands for the number of months since January. So if it's been 0 months since January, then I'm still in January. The lowest temperature occurs every January. What is that low temperature? Again, I think you can see it right on the picture here. Count the tick marks, 10, 20, 30, 40, 50. It appears to be right at 50 degrees. Question C, when does the highest temperature occur and what is that? Again, from the graph, here's the high spot, and coming down here, I think you can see that's happening at x equals 6. So let's see, February would be 1, February, March, April, May, June, July. The 6 would represent July. So every July, this function says we have the highest monthly average. As far as what it is, I'm not sure we can tell from this graph. I don't think it comes out to be a perfectly nice value, but if we go back to the calculator, we can easily find it. I would just use that trace function, and then I would type in 6, hit enter, and then I'll have it. So it looks like 6 months, which we've determined to be July, goes with an average daytime high of 96 degrees. And then lastly, what is the average daytime high temperature for March? Well, it's just the same idea. We got to figure out when March is. March would be 2 months after January. So I would go to x equals 2, head up to the graph, and again, I'm not entirely sure that that lands at a nice spot, so we'll go to the calculator. Still in trace mode, I can simply hit 2 and then enter, and I get 61.5 degrees. Now, I hope you realize that you have the ability to answer these questions by hand as well without the aid of a graph. I do have the equation. If I want to know the average daytime high in March, I can just go to this equation and stick in x equals 2. Let's see, 2 take away 3 would be -1. -1 times pi over 6 would be negative pi over 6. And then we need to work out sine of negative pi over 6, but we know how to do that. I can quickly draw in my reference triangle. Negative pi over 6 is negative 30 degrees. That means I have a 30, 60, 90 triangle. We know how to label those sides. Let's see, I'm in the fourth quadrant, so the 1, the y value there would be a negative. And the sine ratio is clearly -1 opposite over 2, hypotenuse, -1/2. Well, 23 times -1/2 is -11.5, and when I add that to 73, I get 61.5. I get the same answer. So the equation and the graph are all connected. You're beginning to see the power of the trig functions. Thanks for watching.